record. So the percent symbol, we got to remember, is shorthand for divide by 100. So regardless of what's on the other side here, whether I have something like 7 or 75, the symbol literally means divide by 100, no matter what symbol we choose to write it as. And again, that symbol is shorthand for /100, dividing by 100. 7% is 7/100ths, whether we write it as a fraction or a decimal. So changing to a regular number from a percent is pretty easy. We can just say, hey, divide by 100, there's a fraction, or change it into a decimal. Going the other way, instead of taking a percent to a regular number, if I want to take a regular number and turn it into a percent, like suppose I had 35 thousandths, I want to know what that is as a percent. The trick there is to multiply by 100%, because 100% is 1. So we're just multiplying by 1, which really doesn't hurt the number. So if I take 35 thousandths and multiply 100 by 100%, and then I just leave the percent symbol but clean up the times 100, then I'm going to get 3.5%. So 35 thousandths is the same as 3.5%. So the trick when I want to change a regular number to a percent is to just multiply by 100%. So percent basics there. Now we went a little farther with percentages by making illustrations of them, and we had 2 forms of illustration. So as far as the illustrations go, we could either make a 10 by 10 grid, or we could use some kind of rectangular bar, what I called a 100% bar. And so we have a couple of different ways to take that on. In particular, I use these to try to solve problems that are a little more difficult. So I was using them to try and solve percent increase and percent decrease problems. Visualizing the solution can help us figure out what's going on. And there's a few examples in the book too, in section 6.3. So if you haven't checked out the book examples, where I use a bar most of the time for these, they use the 10 by 10 grid. They're both good. Oh, oops, wrong button. So let's try where we have a sale going on, and that sale is 30% off. And the thing about a 30% off sale, if the base amount, the original price, we always consider to be 100%, then the sale price is always 100% minus whatever the percent off is. And so this is what we pay, right? That remaining portion. And so with percent increase and decrease, super important that we have a base of 100% to work with. Can you get by without that? Sometimes yes, sometimes no. So the first problem here, we could get by without it. So suppose we started with an original price of, let's say, $90. What's the sale price? And so I just want to do this by drawing a picture, and we could use a 10 by 10 grid, but in most cases I think it's easier to draw just a rectangle. And the key about the rectangle is you got to demonstrate 100% in some way that you can easily show 30% in a proportional way. So the accuracy of your drawing is important. So I'm going to head out. I'm going to make every other one. So there's 10, 20, 30, 40, 50, 60, 70, 80, 90. All right, so if I counted right, that should be 100% right there. And double check. And if you don't, I mentioned this last class, if you don't have graph paper, use lined paper and make some kind of ruler if you don't have a ruler either. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Perfect. So this is my 100%. And that 100% is the original price of $90 also. So in this bar, I can match up things that are related. 100% original price. Then I can make a note of my 30% off. So from 100%, I get 10, 20, 30% off right here. Which also shows me that I pay 70%. Right? Because here I have my 10, 20, 30, 40, 50, 60, 70% over there. And sometimes it's nice to draw these bars in. So maybe I'll draw some dotted lines to show my 10% marks. Now, I have broken this up into 10% chunks. There's 10 of them. So $90 can also be split up into chunks. So for example, $90 split into 10 pieces means each piece is $9. And sometimes it's nice to draw that in there. So this is $9, and that's $9, and that's 9, and that's 9, and that's 9, and so on. So we could make a note here that in this section that we pay, there are 7 groups of $9. And so we can see that we ought to pay $63. So we can just kind of play around with the picture, thinking about a little bit of division, and come up with sale price. So the goal of that activity was to think about either a bar, which is my recommendation in the picture and what I taught in class last time, but you could use a grid too. So I'll show a grid too just for fun. Sometimes a grid gives us more detail than we need, but sometimes we need that much detail. So with the grid, you got to make yourself a 10 by 10 area. So then I have to find a place to mark off 10 by 10. So let's suppose we start there and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then across. All right, so here's our grid. If you're not the best drawer, a ruler is a nice thing to have. Even with my ruler, sometimes I miss a little bit. That's a little better. And in this case, it's a little bit overkill, so I might pick a different example. So here's my 10 by 10 grid, which represents 100%. And every one of these squares, right, is 1%. So each one of these things right here is 1%. And so maybe I could stick with the 30% off, but pick a different starting price. So maybe my original price this time is something like $400. Now, since there's 100 squares in there, so again, that's why I was saying I don't always like to use this one. Each square can be worth a certain amount. So if there's 100 squares in here and the original price is worth $400, how much is each little square worth? Chat. Anybody with me? How much are these little square worth? if the whole original is worth 400?
Would it be $4?
$4.
Yeah, it'd be $4, right? There's $400, so I take my 400. There's 100 squares to split that up in, so each square would be worth $4. Now I'm not going to draw 4 100s, but I'm just going to make a note of that. And then here we could mark off our 30% off. And this grid works for numbers like, what if it was 32% off? That's easier to show here than it is to show here. With the bar, you can easily do like 10, 20, 30, 40, 50, or even fives, like 25, 35, 45% off. Once you start going into single digits, then it gets a lot harder to draw. You have to start using the 100% grid. And sometimes you will see that in the textbooks with kids. And there's some examples of this in the book where they do that. So let's say shade our 30% off. So 1, 2, 3, if we put a mark right here, and say this is our 30% off. Shade it. So we get this much off, and we just have to pay the remainder. My divider line. Didn't do the best job of coloring in the lines today. Oops. There we go. And so this is the 70% that we pay. And so we can look at it a bunch of different ways. Since I broke it up into 1% chunks, $4 per square. So each square is worth $4 or 1%, as we noted earlier. Then I have 70 of those $4 squares. 7 times 4 on a good day is what? 28? So $80 is what we should pay. So the goal of these is to try and come up with an answer by using the picture to motivate it. And then the picture can also be used to motivate the proportion, right? So the things I'm interested in is what do I pay? Here, and then back in this other problem, I was trying to find that also, what do I pay? And the picture can also be turned into a percentage because we were able to identify that if this is the cutoff between the percent off, what we started with and what we pay, we found that this mark, in addition to being 70%, also is the amount we pay, that's 63. So 63 goes with 70%, just like 90 goes with 100. And so usually when I set up proportions like this, I like to write them. So the proportion's a secondary, way to do it. Initially, I wanted us to do these by the pictures. So here, I am interested in the sale price compared to the original. Percentage-wise, it's 30% off, so we're paying 70%. Originally, we pay 100%. So we have our percent fraction, and then we have our dollar fraction. And so I don't know what the sale price is at first, but I know it was originally 90. And you can see the relationship. This is what I didn't know there out of 70. So those are my numerators, and then the 90 out of 100 are my denominators there. But I think it's also a good idea to write in words what your proportion numerators and denominators mean, or what each fraction means, or both. All right, let's try another one. Let's make this one a little bit harder. So let's stick with the 30% off. And this time we know the sale price. Let's say it's $91. Oops. Question now is, what's the original price? And so what I'd first like you to do is forget about a proportion on this one. Try to draw a rectangle like I drew here, and relate where does 100% off go? Where does the sale percentage go? Where does the sale price go? Where does the original price go? So try to draw a rectangle for this situation. Don't worry about solving yet, just try to draw the rectangle. So it's going to be like this rectangle over here, but we have slightly different information. The only thing that's the same is the 30% off. And we're given the sale price. Last time we had the original price and we found the sale price. This time we're going backwards. So step one, draw this as a 100% bar. And then we'll look at how to solve with the 100% bar. Give you a second to draw that. So first step is have a bar that's equally marked with, in this case, I'm going with 10% because I have a percent that's a multiple of 10. So I have each of these rectangles here, squares in this case in my drawing, that represent 10% chunks. If that was 35%, I would split this again into 5% chunks. So the question is, does the $91 go above the 100 or does it go above the 70?
Above the 70?
Yeah, it goes above the 70. So right up here, I'm going to mark, let's make that bolder. That's my $91. And what we want to know is what's the original price. So that's this over here. Original has to go with 100%. So how could I use this picture to try and solve this problem? What could I do next? Any thoughts?
Could we do 91 divided by 70 to find out how much each?
Yeah, each chunk here. Yeah, so the 91 and the 70, they basically mean the same thing. And the 91 and the 70 each are shown as having 7 equal parts. Now the percent part is easy. We can look at that and say, well, yeah, I made it so that these were 10%. Now we just have to figure out what these are if that total is 91. So to figure that out, we just take 91 and divide by 7. And 7 goes into 91 how many times? 13? Is that right? Anybody?
Yes.
Okay. So we have now $13 per piece up there. So each of these is worth 13. I could fill that in here. 13, 13, 13, 13, a whole bunch of 13s. How many 13s do we have total for the original?
10.
10 of them, right? So the selling price had to be $130. Now we can check that to see if it's true. Usually, you know the original price. You multiply that by, in this case, the percent we pay, which is 70%. And so I could check on my calculator. what is 130 times 70%? And I get the $91 that I started with. And in order to do this problem, though, you have to think out of 100%, otherwise you can't possibly get it right. So an error people make here a lot, let's make a note that this did check. We'll look at the proportion to solve this next. I did get $91, right, when I calculated that. So this did check out according to my picture. All right, so we're on a pictorially solve this. So it's a problem-solving strategy. Common error is people want to apply the 30% right away. So they say, well, we should just take 30% of 91. So they would say, okay, let's take $91 times 30%. Try this and see where this goes wrong. So 91 times 30%, that gives me 27.30. And they assume that this is the amount off. Well, if that's the amount off and this is the sale price, then they would next add that back on to the $91. And what does that give us? 9, 10, 11, $117.30. What went wrong? So this is the most common error in trying to solve this kind of problem. What went wrong here? Seems kind of reasonable at first glance.
$91 is the sell price, so that's already 30% off of the original.
Okay. And
That's what I was going to say.
Okay. Yeah, so the big problem here is we're applying 30% to the wrong number. The 30% is applied to the original price, but we don't know it, right? So we have that catch there. However, we do know that the original price has to be 100%. So in a problem like this, you really need to use that out of 100% to solve it. So to fix this common error, we have a couple of options. One is the picture. Oops, button. The other alternative is to note that if it's 30% off, right, that means that we pay 100% minus 30%, which is 70%. And if I knew the original price, I should be able to take 70% of that original price, and that's where the $91 comes from. So if we realize that 30% off means we pay 70 times the original is the 91, then we kind of have an equation here. 0.7, if we want to use an x, equals 91. And then to solve for x here, we would just divide by 0.7. And if we check on a calculator, what is 91 divided by 7/10? And we're going to get that $130 that we got correctly from the picture. And so I just want to come back to the picture to kind of figure out this, because this isn't always obvious to people. But the picture is nice because it helps us visualize what does 30% off mean. So I just want to redraw that picture again. Think about that. 10, 20, 30, 40, 50, 60, 70, 80, 90, almost long enough, 100. And then we mark our special numbers. So I have my 100%. I like to write the percent in the bottom. Doesn't matter too much as long as you're consistent. I know I have 30% off, so that 70% is important right there. And I can show my 30% off. And so we can differentiate between these two things here. We have our percent off, over there, and the percent we pay over here. Right, so we have a percent off, we have the percent we pay, and we know, right, that the percent off gives us the sale price. So this over here has to be our $91. And then here's my missing number. We can call it anything we want. I like question mark as a variable. And then there's two ways to look at this picture. Now, I like to look at it in terms of sale price over original. And so according to my picture here, as far as percents go, the sale is 70% is what I pay out of original 100%, compared to the sale of $91 out of original, I don't know what it is, question mark. So that's one way to set up the proportion looking at this picture. The other way to look at the picture is you can actually stack just the way you see it here. And you can say 91 is to 70 as what is to 100. And so solving that will also give you the answer. Okay, so in the switch is, instead of having a fraction or a column for percents, I have a denominator or a row for percents, and my numerators are dollar amounts. This fraction is the sale information instead of the numerator being sale information. Can you see how I just kind of twisted rows and columns up here to get down here? And either way works, either one solves it. But the picture can lead to the proportion and avoid that common error of applying 30% to the wrong number. So that's visualizing what percents mean can help people think better about them. Questions on these last couple examples? Okay, seems like we got no questions. Let's try something else. So the other type of problem in that percent section were percent markup problems. And again, each of these problems I pulled from your homework. So if you want more practice with these, go take a look at the homework in section 6.3. There were 4 problems. No, there were more like 6 problems that were like these right here in various contexts. Some of them were percent markup, some of them were percent off, and some were just comparisons through ratios with pictures. And those are important visuals, I think. All right, so percent markup is pretty similar, except we're going, instead of decreasing from 100%, we're increasing from 100%. So percent increase. In the retail world, that's called markup. And let's play with a markup of 40%. So the way markup usually works is you're a business and you buy stuff. What you buy stuff at is called your wholesale cost. So let's say we have a wholesale cost of something like fancy teacups, and a fancy teacup is $20. So a lot of us have these metal double-walled cups that keep our tea or coffee or whatever we're drinking colder longer or warmer longer. And then we want to mark it up by 40%. So we start off with this $20 thing, we mark it up 40%. So the slow way to do this is to say, what's 40% of 20? And so that's 40 hundredths or 4/10 reduced times 20, which I believe on a good day is $8, but never be too safe. When it counts, 40% times 20 gives me $8. So from the percent markup, I get the amount of markup. And it doesn't matter what the original thing was, I just multiply by 40% to get that. And then I can get the selling price the slow way by just adding that back on. So I take my $20, I add on my 40% increase, and so I'm going to put this on the shelf for $28. So let's look at this as a picture. What does this look like as a picture? So let's start off down here, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we always have to know what 100% is. And I have my 10% marks with a little extra space. And then we got to mark it up. So maybe I'll do that in red. I want to mark that up another 10, 20, 30, 40. And you want to be proportional. If 10% was two spaces wide here, make sure 10% is 2 spaces wide there. And if you're not the neatest person, which I'm not some days, a ruler helps, graph paper helps. Use whatever tools you can to make it better. So here is my 100% down there. Maybe I can even shade that, make it prettier. And my increase. And so the nice thing about showing that increase is I can see, oh, 140% is another number I could work with instead of just 40%. So again, trying to get that visual understanding of what the percents are. In this case, I was given the wholesale. That's what I started with. So that's my original here. That's what the markup is based on. And so that's where the $20 goes. And then we calculated that this was $28 total when we marked it up. And so we could also think about breaking this up into pieces in 10% chunks for fun. And what would each of those chunks be worth? If I split 20 into 10 groups, that means each group would be worth $2. And so I can visually see the extra $8 that's going on in there. And then this allows me to solve harder problems too. So a lot of things this picture gives me is an alternative to the slow way would be to just say, starting with $20, find 140% of that. So we can double check on our calculator that 20 times 140% is $28 that we thought it was the slow way. Now, one problem, I mean, the slow way is great, right? That's how it works. We can actually say, hey, mark it up $8, right? But the bottom line, what do I care about? I care that I paid $20 for it and I'm going to sell it for $28. So it's the beginning, the 100% and the 140 that are kind of more meaningful than the actual 40% markup. What did we start with? What did we end with? Other things I can double check here. If I take the ending price, the $28, and I divide it by the original price, the $20, what is that going to give me? Think about that for a second. It gives me 140%. Which my calculator called 1 4/10. Or if we want, we could put a 0 on there, 1 40/100. And just a reminder about what this number means here, that 1 is 100% right there, which references my base amount, my $20. And this 40% right there, that 0.4 right here, is my markup of $8. All right, how's it going? Making sense?
Good.
Good? All right, so I'm going to give you guys one to do and see if we can agree on the answer. I just broke my calculator. All right. So I'm going to do a similar problem. We're still going to do a 40% markup on wholesale. But now, instead of telling you the wholesale price, I'm going to tell you the selling price. So I don't know the wholesale price. But I know it sells for $175. So what I want you to do right here is I want you to draw a picture of this, like this picture right here. So set up your picture for this. 40% markup. Selling price ends up being the 175. We want to use the picture to figure out what the original price is. So the difference here between this time and last time is this is where the 175 goes. I need to figure out that right there. And I want to try to do it with outer proportion, see if somehow I can look at the picture and figure out how to make this happen. And so in this case, I picked a nice percent like 40, so I can do 10% chunks here. So how many 10% chunks are needed to make 140%? Oops, I did that backwards. Right, there's 14 of them. 10 of them to get 100%, 14 to get here. 175 is also made up of 14 chunks. How big is each chunk? How many dollars is each of those 14 chunks worth? Anyone?
$12.50 or 12.5?
12.5, yeah. Now, I'm feeling lazy. I don't want to write every one of them in there. But I know now, by doing a little division, $12.50 or 12.5 just as a number is our missing number here. Oops, I shouldn't write equals there. Box is 12.5. And how many of those chunks make up the 100%? Well, there's 10 of them. So this right here should be 10 times that 1250 or $125. Because each of these is worth 12.5 or 10%. All right? So we can use the picture to kind of look at how many chunks there are and think about how to split them up. You can always check with the proportion. And there's two ways, again, to set up the proportion. We could look at wholesale versus selling price. The wholesale is my 100%. I'm just going to write as 100. And the selling price is my 140%. I'm missing that wholesale dollar amount, but I know the selling dollar amount is that 175. So I could use that proportion to solve it. Or you could kind of just look at this picture and set up an alternate proportion where we say, what is to 100%? What dollar amount is to 100% as the $175 is to the 140? And so either of these proportions will solve this problem. There's power in understanding how the percents work together, and the picture illustrates that. If somebody gives you the picture, it's a lot easier to do. For you guys being future teachers, I'm trying to get you to understand where the pictures come from. Okay, so I think that's a sufficient review of the percent stuff that we've done. Back up my notes here. Pause the recording.